Now, we're going to actually use repeated multiplication to help us get the answer as a single power. Then we'll start using the rule. But if you don't get repeated multiplication, you will never, ever get the rule. So we're going to use brackets around these as we write these in repeated multiplication. So the first set would be 3 squared, 3 times 3. The second set would be 3 cubed, 3 times 3 times 3. Now what if we combine them together? What would our power be, noticing that we have 1, 2, 3, 4, 5 of them? Dustin? Yeah, 3 to the power of 5, or 3 to the exponent 5. Okay. Now the next one is going to be very similar, isn't it? So we're going to have 2 brackets. Please fill them in. The first one is 4 2's. The third one is 3. 4 and 3. How many altogether? 7. So we are actually multiplying the bases together. We're multiplying the 2's. And then we write it as a single power. So here we would have, what? 5 of them. And then altogether, exponent 10. So what would be a rule that we could use to shortcut the repeated multiplication? Here we have a 4 and a 3, and we can get 7. Karen Joe? Add the exponents? Okay, so if we have 2 cubed times 5 squared, we should get something in the exponent 5. What should we put here? 7? I think we need some more to our rule. Pardon me? Yes. If you're multiplying, if you multiply the same base, comma, then add the exponents. I know, but we do have to be specific because we're going to see today you can't always do this rule because you're adding them, or there's different bases. I know. I totally get it. Okay, so next we're dealing with quotient of 2 powers. Quotient's an answer for a division question. So what we're doing is we're doing division. We're going to write this out the long way. On top, we should have 5 of them. On the bottom, I'm going to get them to line up. What's 4 divided by 4? 1. And 4 divided by 4 again is 1. So they cancel out. So how many are remaining? And that's our exponent, 4 cubed. Now, if they're written in this long way, that's okay. We would rewrite it as a fraction. You show me what it would look like. So these should be canceled. Final answer, 12 exponent 2. Okay, specifically, careful now, what's the rule? Dustin? So we can cancel them out. What are we technically doing? Right. Olivia? Good. So up top it says when you multiply. So here it says when you divide. same base, comma, you subtract the exponents. That way, you're canceling. So here we have a 5 and a 2, and then when we're done over here as a single power, we have a 3. So we can take a shortcut. Just like 6 and 4, if you subtract them, you will get a 2. Okay. All right. So what I want to do now is go to this next page. Okay, so let's use our rules real quick. So we have 2 cubed times 2 squared. That's going to be 2 exponent 3 plus 2, 2 exponent 5. So our goal, eventually, we're going to be doing this just with letters. That's what we do higher power math. So it'll be x3 plus 2, x5. So when the bases are the same, we add the exponents when you multiply. Okay? Good. So here I want you to apply the rule. 5 exponent 4 plus 6 equals 5 exponent 10. Okay. What would this one be? 4 exponent what? Please show your work. 4 plus 6 plus 5, 4 exponent 15. I'm not writing down the work for my own benefit. Trust me, I know how to do this stuff. Okay, what's the work on the 3? 2 plus 6, so -3 exponent 8. Okay. The next step, we go to a calculator and figure out the value. But we can do a lot of work with no calculator, and that's your goal. You shouldn't be touching a calculator very much. Okay. Any questions about multiplying? Next, we're dividing. We subtract, so the work is 6 minus 3, and we should get 2 cubed. Okay. Now, for the letters, you can write it any way you want. It doesn't matter which way you write it. It's still 6 minus 3 x cubed. So dividing when bases are the same, we subtract the exponents. Okay. Okay, please do that. Answer A, B, and C right there, please. Ooh, C's a tricky one, isn't it? So 2 and 7, what should we do with those? Add them, yeah. And then what should we do with the 3? Good. Final answer then, 6 exponent 6. All right. You guys like that because you know English. Okay. So next rule now. If we wanted to expand this, we would expand that as 5 cubed times 5 cubed. And then we expand that as 5 times 5 times 5 times 5 times 5 times 5. How many 5s are there? 6. So, 3 plus 2, if we added them, would we get 6? No, can't add those exponents. If we subtracted them, 3 minus 2, would we get 6? Nope. So what do you think we're going to have to do to get 6? Multiply. Exactly. So x exponent 3 times 2 equals x6. So that's a power raised to an exponent. Then we multiply the exponents. Watch out for hidden 1 exponent. Okay, watch out for the hidden 1 exponent. So, A, what's the answer? What's your work, please? 2 times 5 is your work, which you should write down. Right, Tim? Cool, don't be guilty. Just say yes. Of course I am. Just messing with you, Tim. Yes, Sarah?
Because isn't the other rule you add or multiply?
Right. So, think about what the 5 exponent means. Oh, do I have too many? Nope. So if you added the exponents, how many would you have? Okay, so and that's going to happen this unit, you're going to get mixed up. Think about expanding it and seeing what makes sense, okay? That's how you can sort that out, because that will happen, it always does. I see it every year. Okay, next one. Keep the -3 in brackets, tell me what to do with the exponents, and then tell me the answer. 2 times 6, -3 exponent 12. Okay, let's find an answer to this one right away. What would be in simplifying that? 4 exponent 6. Now I'll simplify it again. What's the top and what's the bottom? 4 exponent 8 over 4 cubed. Now go to one final single answer. Any volunteers? Nelson? Awesome. Good job, Nelson. 4 exponent 5. Pretty cool stuff, right? Following the same rules, applying them different ways. Okay. All right. Now we're going to use that same rule down below here, but it gets a little bit different. It's the exact same rule. What's the exponent on the 2? We never write it, but it's always there. 1, and that's the key. So for on the 2, it's going to be 1 times 3. And what's the exponents on the 3? Because we multiply the exponents, just like up above. So a final answer then, 2 exponent, 3 exponent, 6. Okay. Please show your work for the x and the y. And then final answer. Really important here with the work, folks. Be careful. Who wants to take the challenge? Anyone? Dawson?
The x will have an exponent of 1 times 3.
Bingo, that's awesome. 1 times 3. Good job.
And then it would be x with an exponent of 3, and y with an exponent of 9.
Winner, winner. Chicken dinner. So the key to remember when you have exponent outside the brackets, the exponents multiply inside. Not just move. I just didn't slide the 3 into the x. I multiplied it in. And that's how you got to remember it. Okay? So over here, I want you to show your work. Okay, show your work for all of these. Go. Yep. It's going to be 1 times 3 again. So you don't change the 4 at all. You just go 1 times 3 again. Because they both have a hidden 1 exponent. See, I wrote them in there in red now. They both have a hidden 1. Okay? So then your answer would be 3 cubed times 4 cubed. Okay? Okay, do the next one. So this should be 1 times 2, 1 times 2, negative 3 squared times 2 squared. The last one we already did over there, okay? So you don't need to do that one again. All right. So now we're going to apply this rule of fractions, and this is where you guys start messing up. It's not any different than what we just finished doing. Keep in mind this equals 3 over 4 times 3 over 4 times 3 over 4. That's what that exponent of a 3 means. So, does it apply, the exponent only apply to the top of the fraction?
No.
Does it apply to the bottom? No. Well, just the bottom? No. The whole fraction? Yes. So really what we have is the hidden 1 exponent. It's there. We will times 3 times 3. So this equals 3 cubed over 4 cubed. Okay. The top and the bottom are both cubed. So here, showing your work, don't just move it inside, because that's going to make you forget that you're actually multiplying it inside. So the exponent on the outside, multiply, I screwed up there, multiply the outside exponent with the exponents on the numerator, or top, and the denominator, or bottom. So to show your work properly over here, 2, what's the work on the 2? And what's the work on the 3? Good. 2, 4, 3, 4. Good. Try it for B now. Go. So it should be 2 exponent 1 times 3 times 3 exponent 1 times 3 all over 5 exponent 1 times 3. So it's going to be 2 cubed times 5 cubed, 3 cubed over 5 cubed. And last one, work on the last one, please.